guys. Welcome to another edition of Patio Productions Pre-Calculus on Mrs. Fox's patio. Today we are just going to go a teensy little short video because we actually finished our material for chapter 13. We're done. Isn't that exciting? Yay, we're finished. But I'm not sure that it's like stuck in your brain yet, okay? So you found out this weekend that we are going to be doing a test on chapter 13. We have this week. Next week is actually spring break. And then the week after that is where we're going to be specifically prepping for our exam. And we are going to do an exam on chapter 13. It's going to be multiple choice. We're going to do it in Google Forms, all sorts of fun things like that. And so this week, what we thought we would do is just let's bring it home. Let's make sure everything that we learned in all of our sections when we did the right in a row, make sure that it's stuck. And so we're actually going to do two fast track activities. Fast track is that game that we played during class where you sit in rows and you get to move. It's kind of like speed dating, but instead we're just going to have you do the worksheet at home. And then we're just going to post the answers. And then you guys can check your work on these answers. And I thought to myself, that could be it. That could be your whole assignment. And then I was like, well, maybe a short video reviewing all the concepts would be a good idea. And so today's video, which is going to basically take care of 2 days because you're going to have 2 days to work on this assignment because there's kind of a lot of questions. So spread yourself out, like take your time. This is just going to review the quick concepts, no examples, just like the ideas from section 1 through section 4. So let's go ahead and get this PowerPoint pulled up for you guys. And we will, here we go. Let's do this. So these are our fast track activities, okay? And it's just, again, just like the concepts that are going to be in the first 4 sections. So there's, 20 odd questions. I think there's more than 20 questions on reviewing just the first 4 sections. And then we'll do another one of these videos and another worksheet reviewing the next, the second half, the section 5 through 8, a little bit later. So again, this is for 2 days. Okay, guys? So very quickly, I want to make this as short as possible. These are some highlights from sections 1 through 4. So one of the things that they're going to ask you to do is to write out certain terms. Literally, all you're going to do is probably they're going to give you like a rule to follow. And then what do you do? Well, you just plug in the numbers, right? So you start by plugging in the number 1 to wherever there's an N, and then you plug in the number 2, and then you go up to however many it says to get the number of terms, okay? There is also, they'll just give you a sequence, and then they'll ask you to come up with the explicit formula. Now, remember, an explicit formula is one that you could use to find any term. Like, here's the rule, and then go find the 20th term, the 60th term, the 100th term. So you just are going to have to look for a pattern to the numbers. These first ones that we learned, you had to be a little bit more creative, okay? So you are, in fact, trying to look for a pattern, okay? You're looking for a pattern. Sometimes the pattern is an addition guide, a subtraction guy, a multiply guy, a divide guy, but then we can do even craftier ones like perfect squares or perfect cubes or add 2 and subtract 1. It can be something clever like that. So also you might have a different pattern for the numerator versus the denominator if there's a fraction. So go ahead and look at that, right? Yeah, it could be a different pattern for the top and the bottom. There's another thing that they ask you to do called a recursive formula. Okay. And so if they ask you to do a recursive formula, you're going to set the first term and then how you get the next term as it relates to the term before it. That's what a recursive formula looks like. So there's always like an A sub 1 is equal to something. And then they go A sub n is equal to, and then there's something over here relating to the A sub n minus 1 term, something like that, okay? Another fun highlight is doing specifically arithmetic sequences or specifically geometric sequences. And these guys had like ready, nice, canned formulas for us to use. I know, I love it. I love when there's a nice formula to use. And so this would be the explicit formula for an arithmetic sequence. We say that a sub n is equal to a sub 1, the first term, plus n minus 1, and then times d. D is, again, your common difference. How do you get the common difference? You can take any term and subtract the 1 before it, and that will give you the common difference. Okay, we can also have an explicit formula for geometric sequences. Geometric sequences would look like this. This is the explicit term. So you would have your nth term, and then again, you have your first term, and then you have your common ratio. How do you get the common ratio? You take a term and divide by the one before it. And then this is to the n minus 1 power up here, just like that. When we evaluate these, of course, for both of these guys, you got to watch your order of operations. And then especially up here on this arithmetic, if this D is a negative number, go ahead and put that baby in parentheses. That would be a good choice. To find a specific term, once you figure out the rule, you just plug that n value into your formulas and you are good to go. All right, what else is in these first 4 sections, okay? There is arithmetic means, the idea of arithmetic means. Now, the idea of arithmetic means is, this is kind of just like an example that we had from notes. I'm not going to do it, but this is the process. You write the first term, and then however many means it wants you to do, you put like that number of blanks, and you put like a comma after everything, and then you do the last term. Your common difference that you're going to find that allows you to get from one term to the next term is going to be the last number minus the first number, and then divide by either the number of commas or the number of changes, and then that will allow you to get the common difference, and then you can fill in all these numbers. The answer would be all of these numbers that got filled in to your sequence. Okay, geometric means you do the same thing, okay, where you write like the first term, or like however many however many terms they're putting in. You write the first one, you write the last one, you do the spaces in between. But this time, because it's a multiplication problem, you're going to take that last number and divide by the first number, and then take the root that is how many jumps or commas there are. A lot of times, and this is why this one has 2 different sets, sometimes there's 2 different sets of answers, right? Fancy. Okay, and the 2 different sets of answers are because maybe you're taking the square root of something or the 4th root of something, and you get like a plus or minus guy. So that means you would need to have 2 sets of different answers. When you write things in sigma notation, okay, this is what I don't want you to think. No, don't think that. I want you to think this. Because sigma notation is very cool, very nice. Sigma notation means that all you're going to do is you're going to write a sigma. You're going to indicate what number you're starting at and what number you're ending at, or maybe this top number might be an infinity. It just kind of depends. And then right here next to it, this is just the rule. Okay, whatever the rule is. Maybe it's random, maybe it's arithmetic, maybe it's geometric. I don't know. Put the rule there and you will be golden. Okay, so sigma notation, do not be afraid of sigma notation. It's something that we definitely need to be just like absorbing and focusing on as we build up our mathematical strengths and powers. Okay, another fun thing that happens is, since we're talking about sigma, that sigma means to add up, okay? So maybe it happens to be a special, very specific arithmetic series. An arithmetic series has a formula for its sum, okay? And if we're going to find the, say like the 10th sum or the whatever sum it is, you're going to say S sub whatever number they want. You take that number and you divide it by 2, and then you multiply by the sum of the first term and then the last term. Now, this one is very beautiful, but it may not be efficient. You may want to use this one instead. This formula, if you remember, is the exact same thing. It just means that you don't have to specifically identify the last term. Instead, what you can do is just find your common difference right here and then use double times the first term. This is actually the exact same formula as this one. They just put in the a sub n formula into this guy and cleaned it up a little bit. So either one of these will give you the sum of an arithmetic series. There's also the sum of a geometric series. Now, notice I am using the word finite here. That's because there's another theorem when we do an infinite geometric series. So this is just saying like the sum of the first so-and-so number of terms, and it looks like this. I know, it's pretty. Okay, but you really had to watch your order of operations on this one, right? It is very, very easy to get this one wrong. I know, and it's because you're not doing order of operations. So please don't fall for that trick, guys. Make sure you're doing your order of operations. So it's the first term times 1 minus your common ratio to the end. It might be wise to put your common ratio in parentheses, especially if it's a negative number. Okay, so just think about that as you're putting things in your calculator, over 1 minus that common ratio. All right. What other kind of fun things? The last thing that we finished off in the first 4 sections was math induction. So I'm just going to pop up these instructions really quick. Remember, guys, it was a combination of English statements and math statements. Yeah, and you had to have both of them to make it correct. And so like the first thing you're going to want to do is you're going to write down the words prove that p sub 1 is true for n equals 1. You plug in 1. Your second step is you say assume p sub k is true for n equals k, and you really just copy down the original statement and plug in k. Then the hard part comes in down here. It's really not the hard part. It's just the most complicated part, I guess you could say. So, you know, you're just going to get revved up. You're going to make sure it works. You're going to write down prove p sub k is true for n equals k plus 1. And then you're just going to build. I think on this one, it is probably the best idea to go ahead and think about that want bubble. You're going to add that next term onto the left-hand side. You repeat that onto the right-hand side, and then you go to the want bubble over on the side, and you try to figure out what are you going for, okay? And then you work your algebraic magic, and yeah, it is a lot of algebraic powers, but you can do it. You guys, you can totally do this, and we practiced a bunch of them. It's just now reminding you. Remember, you have to finish off with your conclusion sentence that is the same thing every stinking time. By mathematical induction, the above statement is true for all natural numbers. And then you, of course, finish it off with a Q, E, and a D. That is the ugliest E I've ever seen in my life, but you put QED and you are golden. All right, ladies and gents, that's all I wanted to go over very quick, okay? Just kind of like a quick summary all on one page. You're doing the fast track assignment. It is a bunch of problems. You're going to work on it for 2 days. So when you turn this in, it's going to be worth 2 days credit for homework. So please, please, please do it. Don't skip it. And it's in your best interest to go ahead and answer those questions. So we are done with our quick little review. So let me just send it off for you guys. Okay. So again, that's all you're doing, watching this video, spending 2 days going over the fast track questions and submitting it just on Tuesday, but worth 2 assignments. Okay. I think that's it, guys. All right. I'm so glad I got to reach out to you guys. I was thinking about not doing a video, and I was like, no, you got to see me. We got to just make this work. So that's it. So I will send you off with our beautiful fanfare music. I hope you have a lovely day working on your pre-calculus and all your other lovely assignments. Bye, guys. See ya.